All right, let's talk about these compounds. So, oxidation number. Which one's the cation? Which one's the anion? How do you know the hydrogen's the cation? Okay, so how do you know the chloride's the anion? Because the real reason you know is the rule is hydrogen is with a non-metal, so that makes hydrogen +1. So that automatically makes it the positive one. And then the chloride must be -1. It must be -1 because the hydrogen's +1, but it also is -1 because the rule about halogens says it's -1 unless it's with another halogen or something, or with an oxygen, and hydrogen's not. So, and the name of this? What is it doing? All right. Next one. How do you know the cobalt is the cation? It's a metal. That's the reason. It's either 0 charge if it's by itself. If it's in a compound, it automatically has a positive charge. And we're going to give this a +2 charge because the sulfur is in the oxygen column, and so its oxidation state's going to be what? -2. And then the name of this? Close. Nope. Oh, well, sulfide, yes. Not ite.
Oh, is it cobalt 2?
What is going on? You're seeing that, right?
Yeah.
That is really hard to write. Yes, cobalt 2. Huh. How about this? And was it sulfide? Wow. All right. There's definitely something wrong with that. Maybe it's trying to. It doesn't matter. Okay. This next one. So cation or cations. The hydrogen's got a plus charge, right? And then the oxygen has a -2 charge. And so since I've got oxygen -2 4 times, that's 8. And then the hydrogen knocks out 2 of that. And so that means the sulfur must be the rest. So the sulfur has to be a +6. And then the name of this? Okay. Cation with the next one? Iodine. It's probably easier to put the anion up first. What's oxygen's charge then? -2. Okay, so if I've got 8 negatives from the oxygen, but I have to have a leftover negative, what's the iodine's charge? +7, right? And then what's the name of this? Periodate. And the manganese is the cation because it's a metal. And what's its charge this time? 3? Because the iodine's got to have a -1 charge because it's with a metal. And so the name of this thing, this is going to be hard. Sweet. Cool. Manganese 3 iodide. We okay with that? Okay, if a molecule is polar, what's happening?
Mixing
Uh,
uneven charge or uneven pull.
yes. So it's an uneven sharing of electrons. What types of molecules can be polar? And which cannot? How come the ionic ones can't be polar? What's the definition for polar? Uneven sharing, so why can the ionic ones not? They don't share, so they can't have uneven sharing if there's no sharing. So since there's a full-on transfer of the electrons, I can't have an ionic bond having a polar bond. All right, so let's do the structure. Let's name this. Oh, I shouldn't have given that to you. Yeah. You guys don't technically know how to name the first one. Can you name the second one for me? Oh, I just asked you to name each structure. Okay, good. All right. Don't worry about it. Can you name the first one though? The compound? I'm sorry, I meant the second one. You can't name the first one. The Ni3? What is that? Is it just nitrogen iodide? What kind of compound is it? It's a covalent compound. How do you know that? Two nonmetals, right? So you had to use the prefixes. And since nitrogen's by itself and it's the first one, I just say nitrogen. The second one, there's three of it, so I say nitrogen triiodide. You always throw the "ide" at the end of that. You can't name the first one because that's an organic molecule, and the naming structure for that is completely different. It's fluoromethane. Okay, so we're going to draw a Lewis structure. So for the Lewis structure, I've got 4 electrons from the carbon plus 1 times 3 for the hydrogen plus 7. So I've got 14 electrons to deal with. I'm going to put my carbon in the middle, and it doesn't really matter. I'll put fluorine and a hydrogen and a hydrogen and a hydrogen. And I've used how many electrons? 8 of my 14. And my fluorine isn't happy, so I'll put some electrons around it. And so now the fluorine's happy. So there's my Lewis structure. The 3D structure for this is going to be, doesn't really matter, fluorine, hydrogen, hydrogen, hydrogen. What's the shape of this molecule? Tetrahedral? Does this have a Vesper shape? Why not? It does not.
There's not like electrons on the middle.
There are no lone pairs of electrons on that central atom, so there's no Vesper shape for this. And did I ask you about polarity? I did not, but I'm going to ask you now. Is this molecule polar or nonpolar? What's the first thing that you have to ask yourself when you get that question? Is it covalent? This is. Okay, and then what? Okay, is there a difference in electronegativity between any of the atoms? So the hydrogen and carbon, the answer is no. The difference is 0.3. For the carbon and the fluorine, though, the difference is very significant. The fluorine's 4, the carbon's 2.5. So the electrons in the electrons in that bond right there, what's happening to them? They're being drugged towards the fluorine, right? So I've got this going up, so this side of the molecule is negative, and this side of the molecule is positive. So would this mix with water? Yeah, it's a polar molecule. Okay. Next one. So I've got a nitrogen that's got 5 electrons plus an iodine that's got 7 times 3 electrons. So 26 total electrons. I'm going to put my nitrogen in the middle, and then I'm going to put an iodine, an iodine, and an iodine all attached up. So everybody's hooked up. I've used 6 of my 20 electrons. I'm going to tap electrons around each of the iodides to give them 8. That leaves me with 2 leftover electrons. I'm going to put those 2 leftover electrons right there on top of my, my nitrogen. And there's my Lewis structure. Okay. What's the 3D structure for this guy look like? Okay. So I'm going to put the nitrogen here, and I'll put a lone pair of electrons up top, and an iodine there, and an iodine there, and an iodine coming out at you. All right, so this, what's this Vesper shape? Does this have a Vesper shape? Mm-hmm. For sure. And it's got a Vesper shape because the nitrogen has the lone pairs of electrons on it. So what's its Vesper shape? Nope. Not trigonal anything. What is it? It's a tetrahedral.
So the Vesper shape is the main ones that are here, and these are.
Nope. The Vesper shape includes the electrons. Okay, so what is the shape with all of these 4 things around this atom? It's a tetrahedral, right? Because Vesper stands for electron shell pair repulsion, and so those electrons take up a position, causing those iodines to be down. If the electrons weren't there, this would just be 3 things around a nitrogen, and it'd be trigonal planar. But since those electrons are there and taking up a spot, it pushes those iodides down and gives the structure with the electrons the appearance of having a tetrahedral shape. Okay, so its Vesper is tetrahedral, but then I cover these guys up and then ask myself, what's the shape now? And the shape of the molecule is trigonal planar. No, did I say planar? How about if I could spell? It's trigonal pyramidal. So why is it trigonal pyramidal?
Flat?
It's not flat, so it's got to have a 3-dimensional shape. So how come it's not just pyramidal? Why is it trigonal pyramidal? Because the base has 3 sides and a pyramid's supposed to have 4, so I have to specify it's not a real pyramid, it's a fake 3-sided pyramid.